This is the first lesson in chapter 1, the greatest common factor. How can we find the greatest common factor and what is the greatest common factor? Let's know by taking this example. There are online sliced servings of 3 types of cake on a table. Each row has an equal number of servings and only one type of cake. What is the greatest number of servings in each row? Here is a table and you can see the type. Marble, we have 10 number of servings. Red velvet, we have 15 number of servings. And chocolate, we have 20 number of servings. Now, if you take the number 10, we know that we can write 10 as 10 times 1. Also, we can write 10 as 5 times 2. These are the factors of 10. So we list them in order. Factors of 10, 1, 2, 5, and 10. For the number 15, maybe it's 1 by 15. Maybe it is 3 by 5. So we can list the factors of 15 as 1, 3, 5, 15. For the number 20, 20 may be 1 by 20, maybe 2 times 10, maybe 4 times 5. So if we can list the factors of 20, they are 1, 2, 4, 5, 10, 20. Now look at the numbers in red. We have here 1 is repeated in all as a factor of all 10, 15, and 20, and also 5 is repeated as well. So we can say that 1 is a common factor of 10, 15, and 20. Also 5 is a common factor of 10, 15, and 20. Common because it's repeated. But we need the GCF, which is the greatest common factor. So the greatest is 5. So we can say that the GCF of 10, 15, and 20 is 5. Greatest common factor. This is the method of common factors. We have another method is called prime factors. And let's see how we can use prime factors in solving the common factor. Now we need to move on. Lana earned $49 on Friday, $42 on Saturday, $21 on Sunday. Selling bracelet. She sold each bracelet for the same amount. What is the most she could have charged for each bracelet? So the same idea, it's the idea of the common factor. So we take the 49 factors of 49, which are, we have 1 by 49 and 7 by 7. So 1, 7, and 49. Factors of 42. We have 1 by 42. We have 2 times 21. We have 3 times 14. 4 times nothing. 5 times nothing, 6 times 7, and that's it. So we can list factors of 14 in order as 1, 2, 3, 6, 7, 14, 21, 42. Now we need to list the factors of 21. Maybe 1 by 21 or 3 by 7. So it's 1, 3, 7, and 21. Now if you check for the common factor, of course we need the greatest. So the greatest will be 7. 7 is repeated in all factors of 49, 42, and 21, and it is the greatest. So for problem A, we can say that GCF equals 7. Now in example 2, find the GCF of 12 and 18. As you can see, this method is another method is called the prime factoring method. We start with any factoring, no need to mention all of them like before. So 12 can be written as 2 by 6. Also you can start with 3 by 4, it's up to you. So just to make any start, 12 is 2 by 6. 2 will be dropped because 2 cannot be factored in any other prime factor. 6 can be factored into 2 by 3. So the factors of 12 are 2 by 2 by 3. So we can write that 12 equals 2 multiplied by 2 multiplied by 3. Now for the 18. 18 could be 2 by 9. The 2 is dropped. 9 will be 3 by 3. So the 18 can be written as 2 multiplied by 3 multiplied by another 3. As you can see, I left here a space because there is no other 2 as a factor, as a prime factor in 18. Now we will choose the common prime factors. Here 2 is common, so we write it down as 1, 2. Also 3 is common, so write it down as 1, 3. Then we multiply them and we get 6. So the GCF, greatest common factor of 12 and 18, is 2 by 3, which is 6. We can write here in problem B 12 and 66. Let's try to use the prime factoring method. For the 12, as I told you, you can write it 2 by 6 or 3 by 4. I will use 3 by 4 now. 3 stays the same, 3. The 4 will be 2 by 2. So now, for problem B, I can write 12 as, you can see, 2 by 2 by 3. Now let's take the 66. 66 can be 6 multiplied by 11. 11 will be dropped as 11. 6 is 2 by 3. So 66 will be written as 2 multiplied by 3 multiplied by 11. It's important to align the prime factors. So the 2 under the 2 and the 3 under the 3 and the 11 is outside because no 11 here. Now let's take the common parts, common factors. Here 2 is common and also 3 is common. So we can say also 2 multiplied by 3, which is 6. So we can say for problem B, the greatest common factor is 6. And you can notice that both numbers, 12 and 66, both of them is divisible by the number 6. Also here, both 12 and 18 is divisible by the number 6. This is for you to check your answer. Now we need to solve this one, 18 and 30. What do you expect mentally before you solve it this method? What is the greatest common factor of 18 and 30? We know that both 18 and 30 are divisible by 3, but there is a higher number which is 6. Both 18 and 30 are divisible by 6. So the greatest common factor will be 6. Let me show you how. We can say 18 is mentioned here. 18 is 2 by 9 is okay. I can say 3 by 6. The 3 is dropped. The 6 will be 2 by 3. So for problem C, we can say that 18 equals 2 multiplied by 3 multiplied by another 3. Now for the number 30, we all know that 30 is 5 multiplied by 6. The 5 is dropped as 5. The 6 can be 2 multiplied by 3. So for the number 30, 2 multiplied by 3 multiplied by 5. So we put the 2 under the 2, the 3 under the 3, but we cannot put this 5 under the 3, so we put it aside. Now we take a line and we take the common prime factors, 2 and 3, and 2 by 3 equal to 6. Of course, this is a coincidence that we have here the answer is 6 and the answer here is 6. It could be any number. So, according to our solution, greatest common factor is 6. Now for problem D. Let's take the 32. 32 can be considered as, we can say 4 by 8, and this 4 will be 2 by 2, and this 8 is 2 multiplied by 4, and this 4 will be 2 by 2. So look at how many prime factors we have, 2 by 2 by 2 by 2 by 2, because this 2 will be dropped, and this 2 will be dropped, and this 2 will be dropped. So we have 2 by 2 by 2 by 2 by 2. This is for the number 32. Now for the number 48, we can do it here, 48. 48, we can say 4 times 12, for example, or 6 by 8, it's up to you. Let's follow the 4 by 12. The 4 will be considered as 2 by 2. The 12 is 4 multiplied by 3. The 4 is 2 by 2. This 3 is dropped, this 2 is dropped, This 2 is the 4. So the 48 is 2 by 2 by 2 by 2 by 3. Now let's write them here. The 32. 32 is equal to 2 times 2 times 2 times 2. Let's count 1, 2, 3, 4, 5. So another 2. Now the 48. The 48, it's 2 by 2 by 2 by 2 by 3. So 2 under the 2, 2 under the 2, another 2 under the 2, another 2. We don't have another 2, so we put the 3 aside. Now, let's take the common prime factors. We have here 2 is common, another 2 is common, another 2 is common, as you can see, another 2 is common, no other common factor, so 2 by 2 by 2 by 2 will give you 16, means the greatest common factor of 32 and 48 is 16. By this, my dear students, we come to the end of our part of a lesson for today, and till we meet again, goodbye.